My name is Ronald Sudo, and this is my conference presentation submission for cloud development at SNHU's CS470. All right, so, well, I did say that already, didn't I? The purpose of this presentation is to articulate the intricacies of cloud development, both technical and non-technical audiences. Okay, so the model of migration for this project is considered replatforming. Components were slightly modified to make use of cloud services while maintaining their configurations and compatibility. That's kind of the the main idea behind containerization, right? We're going to keep their configurations, but we're going to migrate them in a way that we can still make use of them like elsewhere. The tools necessary for this migration were Docker Compose, Lambda, API Gateway, S3, and DynamoDB. We primarily used Docker Compose for the containerization, and that was done pre-migration. We placed them in the containers, and then we moved forward. So the value of using Docker Compose in terms of orchestration is for the migration process. Docker Compose is a powerful tool for containerizing and manages applications composed of multiple components divided into separate containers. Each piece is kind of put into its own container. They're moved separately and then reconnected later. So serverless hosting is cloud-based and has many advantages. It promotes scalability, production efficiency, cost reduction, service availability, and data security. It's all the good stuff, right? S3 stands for Simple Storage Service. Compared to local storage, S3 utilizes scalable buckets and has built-in redundancy and fault tolerance. And another little bonus is it can use AES 256 encryption. When you're storing things locally, needing more space means you need more hardware. In the cloud, however, needing more space just means your bucket gets bigger. So that is a pretty big benefit. And we're going to look at the API and Lambda functions. The advantages of using serverless API are numerous, from the previously mentioned scalability and cost efficiency to less obvious benefits like flexibility and user-friendliness during development. Those will save you a lot of time during the development process, really. Lambda API logic is particularly powerful because its functions can be accessed and used by multiple sources, such as API Gateway, S3, and Dynamo. Lambda can even support custom functions and events, so you can sort of build your own functions and pipe them together. Lambda functions handle requests through event triggers and scripted handler functions that process input and return responses. So basically, say DynamoDB sends a response, Lambda grabs that response and passes it on. API Gateway calls a function, Lambda handles that function, passes the appropriate information where it needs to go. The steps needed to integrate the front end with the back end are as follows. First, we migrated our Angular HTML to an S3 bucket. We then set up Lambda functions that accessed information inside that. We set up a DynamoDB for storing information. We created API gateways that would sort of connect a lot of these things together. We then implemented IAM permissions. These are role-based permissions that make sure individual functions can access the information they need, but are restricted to only the information they need. And then we connected the front-end APIs, and everything kind of clicked together. Looking at the database, initially we had an application that ran with MongoDB. It utilized JSON-based document storage whereas DynamoDB uses key-based document storage. DynamoDB can also support secondary keys for additional query patterns. In launching our database, we implemented key-based queries. Questions were added or retrieved based on a unique key value. Further, answers could be added by referencing the key value of a question to which they corresponded. So there was that's sort of that secondary key that you're seeing. Like answers would have their own unique key, but they're also referencing a key attached to a question. Accessing these key values required scripts that utilized get functions to pull key values and put functions to add corresponding answers to the database. Pretty straightforward. Let's see here. So now we're going to talk about cloud-based development principles. When we talk about elasticity, it's really a system's ability to grow over time. The elasticity here we're talking about is a high level of elasticity, and it promotes scalability by automatically scaling resources based on usage and project demand. So if we look at this graph, you might plan to be here and you're well ahead of your usage, but if usage increases past your planning, as it does, at this index here, you really have to be able to adapt and to scale more quickly, and this very efficiently and effectively allows for that. Further, there's the pay-for-use model, which promotes cost efficiency by allowing clients to pay for only the services and usages that they consume. So you don't have to plan for a huge project and then end up wasting all that available computing power, or what have you. So here, in terms of access, we can see that unauthorized access is prevented by setting permissions and policies with the IAM functions, and usage of authentication between components. That's pretty important, because it's not only checking as requests come into the application, but also in between the different components of the application. In terms of policies, roles need permissions in AWS, or roles define permissions in AWS services, and policies grant those permissions to only the roles that need them. It's an important distinction. For this project, we granted permissions to the API to read and write from the database, and then granted public permission to add and edit questions and answers, thus allowing users to interact with the application. So there's different layers to that. In terms of security, connections between the Lambda functions and the API gateway were secured using these IAM roles and policies. IAM roles and policies were also used to allow Lambda to interact with the Dynamo database. And then further, we had an S3 bucket, which was used to house static HTML, but permissions are also configured for accessing that component. So each individual piece is secured and authenticated in its own. All right, so the main points here: serverless application hosting is scalable. The goal of any business is to grow, and growth can sometimes be unpredictable or difficult to plan for. So the elastic and cost-efficient nature of serverless hosting makes it an ideal choice for growing businesses. Further, despite data not being stored on site, rigorous control of authentication and role-based permissions makes AWS Cloud Service a more suitably secure option for any organization. And finally, AWS Cloud Services are cost-efficient, not only because they save time and money on the migration and launch, but they also feature usage-based billing, which can reduce wasted resources and allow companies to really only pay for what they need. So I believe that covers all the bases. Thank you for your time. Cheers.